us and all of you for coming. It's great to see so many people here. So today I'm going to be talking about fine-tuning and then what we work on at Outerbounds and the open source framework it's built on top of called Metaflow. Before I get started though, there's two QR codes here, which they're also going to be on this slide. The one on the top corner, that is to the whole slide deck, so no need to take notes, no need to take screenshots with your cell phone. You can just go get the whole presentation is on the internet. And then we also brought some swag. So my colleague Savin is over here by this box. We have some t-shirts for y'all. In exchange for an email sign up to our sandbox environment where you can try out some of the stuff I'm about to demo today, that link on the bottom right, the QR code that will register you so we can get you a free shirt. So the agenda for my talk today is going to be mostly about fine-tuning large language models and how that intersects with Metaflow, a framework that we work on and maintain with Netflix at Outerbounds. So we'll start by giving an introduction to what is Metaflow, kind of more generally thinking about what is task orchestration and how it relates to using large language models and building systems around them. We'll talk specifically about what is fine-tuning, what are some patterns we're seeing in terms of like what folks in the community and what our customers are doing with fine-tuning and when they're doing it. We'll then talk about how to do it. We'll get into specific fine-tuning frameworks and then close out with how do these frameworks interact with Metaflow and how can you get started today building at your organization. I'll try to go reasonably quick through the slides, but if anybody has any questions, just throw a hand up and I'll do my best to try to do things in real time. But if not, you can also hold questions till the end and I'll try and leave 5 minutes. Okay, so Metaflow at its core is a Python library. It's open source, so everything that you see in this presentation you can take and run yourself. And then Outerbounds, the relationship is that we build on top of Metaflow to provide enterprise services for our customers, as well as manage the Metaflow deployment for them. So Metaflow is a framework to help you build real-life machine learning, AI, and data science applications. It comes from Netflix, and we're going to kind of get into the details of how does this Python library that you can see kind of a hello world example of here, how does it connect to all these layers on the right-hand side, which is our interpretation of the machine learning stack. So in addition to being used at Netflix and maintained by them and us at Outerbounds, we have a bunch of customers that are using either Outerbounds distribution of Metaflow or using the open source version themselves. So lots of companies, and it's a very established open source framework. So definitely get started and check it out at your organization. You'll be in good company. The core idea of this talk and kind of a general principle of Metaflow is that a lot of machine learning, when you get started, a lot of the textbooks and things that you might see in grad school, a lot of it's about building models and kind of thinking about how to move data around and push them through models, train models, update the weights, things like this. The idea that I want to stress here is that, especially when it comes to large language models, obviously M is models, so that's what's getting a lot of the attention, is kind of the new version of Claude or the new GPT-4 whatever from OpenAI. But at the end of the day, what really matters is the systems that contain these models, the systems that they're inside of and that they need to connect to in production software and products that you and I use every day. This includes things like being able to switch between different models, being able to deploy and operate the software reliably in production systems, being able to keep track of all the different code that defines the models, the weights that are the data that represents the models, and all the data sets that flow through them. Doing so in developer-friendly APIs, so we as developers are able to kind of trace back throughout the system. And of course, with the first L in LLM is very often in reference to the size of the actual models. We need very expensive and sometimes difficult to use processors to run the compute. And then on this bottom layer, what we mean by data is ensuring that there's secure and very fast connections to wherever the source data that you use to train the model lives, whether this be a warehouse like Snowflake or Databricks, or a data lake like S3, or the equivalent in whatever cloud you use. And then, of course, these things kind of all become realized in the logos that we see on the screen here. Like on the data layer, you might think Databricks, Snowflake, so on and so forth. But we'll get all into the more details of this as we go here. Now, switching gears a bit and connecting to this whole fine-tuning piece, which is the other part of the talk that we're going to kind of move back and forth between Metaflow and task orchestration in this fine-tuning piece. So this picture is from a blog post that we wrote about almost 2 years ago now, kind of like right after the LLM wave really kind of caught the general zeitgeist. And the thing that I want to emphasize here, and we'll come back to at different points throughout the talk, is that fine-tuning, although it's kind of like a fun, and especially for developers, it's a very like sexy, challenging thing to think about. It requires a lot of engineering know-how and getting into the low-level details of how do GPUs work, things like this. But it's a small part in a bigger system is the idea. It can be a critical part, that's the piece that you need to differentiate your AI systems from your competitors, but it's also got to fit with kind of within the context of broader systems like this. Speaking of differentiation, actually, before I go into this slide, maybe this is a good place to pause and kind of see where we're at with the audience. So who here, just by a quick show of hands, who here has called one of the LLM APIs? Could be OpenAI, could be Anthropic, could be NVIDIA has a new product called NIM. Who's called them from a program before? So probably more than half, I'd say about 2/3 of the hands went up. Who has built a RAG application where in addition to calling these APIs, you're actually kind of using your own data to augment the prompts? Maybe a little less than half, but still quite a few people. And now, continuing in this direction, who's fine-tuned that model itself? So who's taken these open source weights, run training loops, and continued updating the weights? Surprising amount. So I see probably at least a dozen, maybe about 20 folks there. So for those of you who don't know what those words are that I just said, which seems like not very much, which is very impressive for the audience, what I'm kind of indicating here is there's different levels of customization in ways that you can differentiate your AI systems from whatever your competitor is doing, just calling OpenAI or whatever, for example. So starting on the left here, this generic LLM, what we're kind of thinking about is like, okay, the prompt that your user sends in through your app or whatever system that you're building around, that's going to be super relevant to the kind of outputs that you desire. However, when you're just kind of calling one of these language models trained on the entire internet, and it's like a bit hard to kind of get it to go into a specific realm or a specific domain, the response quality that you're going to get is going to vary quite a bit. For example, if you try to train it or try to just ask OpenAI in the ChatGPT interface kind of obscure questions about how does Outerbounds product work, it's not really going to be helpful. It's actually going to be more harmful than helpful if we try to expose this kind of thing to our end users. So one way that people kind of the first step that a lot of people do, you don't even really need to be a programmer to start doing prompt engineering, is people have kind of constructed these really long libraries of different prompting techniques and methods, ways that you can essentially talk to ChatGPT and kind of guide it to think more in a certain direction. Kind of extending that direction is this RAG concept, where in addition to modifying these prompts and sort of guiding the model into a specific area of its domain, we're also going to be actually connecting that to a database of relevant information and picking the data that's the most relevant to the original user prompt and including that somehow in the prompt engineering we do before we send that request to the LLM. Continuing, we can now think about, like, well, what if we just want to actually take this big blob in the middle of this big model that's kind of trained on a very large corpus of information, and we want to actually modify that domain itself. Maybe we want to distill down some of the information so that the LLM isn't aware of quantum physics, but is actually an expert in Outerbounds documentation, or is an expert in responding in the specific style that we want to present to our users as they query this system when they're trying to figure out how to use our product. So we're going to be focusing on that aspect here. So again, we're kind of very much in this realm of very, very custom kind of differentiated solutions on top of LLMs. And here I just want to pause briefly and kind of share, these are some insights from folks that I personally trust and have learned from, as well as what we see customers doing, both with the open source Metaflow and at Outerbounds. There's a couple reasons why you might want to fine tune. I think probably the biggest one is some combination of the first one and the third one. Probably should have reordered the list. But where you want to have very domain-specific knowledge, such as some bot that really understands what is Outerbounds product, what are all the APIs that users are interacting with when they do stuff in our user interfaces, things like this. And then leveraging a data moat is another big one. If you have a bunch of data that's not on the public internet, but is extremely relevant to the kinds of things you want your users to be able to do with AI, that's a sweet spot for fine-tuning. Especially when that gets coupled with this idea in the fourth bullet around adding all of this context into what is considered in-domain for the LLM, but doing so in a way that doesn't blow up the complexity of your inference pipelines. Some of you may have noticed, if we go back to what these RAG apps look like, we're adding extra arrows, and kind of the more complex you start to get into this information retrieval game, the more complex each inference becomes when users request something inside of your applications. The final one, which we won't touch on a ton here, but I think is super interesting and is kind of a theme that I'm watching for 2025, is distillation in small language models. SMOL is kind of the way that a lot of the community has branded this. But the idea is basically, okay, there's a small domain where I want the LLM to be very good. Can I kind of distill down the expertise that the model has gained? Say the biggest llama models that Meta is trained on most of the internet, these kinds of things. Can I distill that down into a smaller model that's cheaper to run and is also going to be easier for me to kind of control the boundaries of what it will or won't answer, things like this. Now this is obviously a bad slide with way too many words, but that's by design. The point here is that if you want to do fine-tuning, there's other stuff you should try first in almost every use case that I've seen. Especially like the real mindset that I have here is that fine-tuning works best when you know exactly why you need to fine-tune. So that's why I bolded the fourth and the sixth step here, where 6 is obviously like there's a bunch of other stuff to do no matter what recipe you create before you're going to be able to do fine-tuning in a meaningful way. But with number 4, the only way to really know how to construct the sort of data sets that are going to be useful in order to do fine-tuning on whatever LLM kind of base that you choose is to look at a bunch of text and figure out exactly why the off-the-shelf model isn't responding in the way that you want. As far as I know, doing this is not, you can, of course, make synthetic data sets, but jumping to that place in the beginning is almost always a losing mission. And usually the best idea is to get experts to be looking very deeply at what these patterns are in your data sets and how your users are interacting with these AI systems. Now to bring a little bit, to come a little bit down from the abstraction layer, this is an actual system that we're working on at Outerbounds. So forgive my poor design skills in Excalidraw. But what you'll notice here, what I want to call your attention to, is this SFT workflow in the top right. Much like that picture earlier before, that was a bit more abstract, this is the piece that's actually fine-tuning in our system. And you'll notice that this is there's many databases going on here, there's many different APIs, there's different apps, and all of these things are interacting in a way that makes fine-tuning an actually valuable thing for us to be doing with this data. But without all of the other context around it, the fine-tuning isn't so useful, is the point of the slide here. So now moving towards kind of, okay, like maybe we're convinced, maybe we have a reasonable architecture diagram. How do we actually do this stuff now? If we go back to the slide, this fine-tuning workflow, you can think of each of these little circles. These are each going to be a compute task, a Kubernetes pod, a Docker container, these kinds of processes that you will run to do some kind of fine-tuning, some kind of data processing, things like this. So now with that in mind, kind of imagine what do you actually put in these circles? Like what are they, and how can we start to build them up is going to be the rest of this talk. On the base layer, we need hardware. For inference, a lot of times it's going to be a CPU. It can also be a GPU. For training, fine-tuning, this is almost always going to be a GPU. 99% of the time going to be an NVIDIA card. These task containers, these are what Metaflow is fundamentally designed to do. There's also great tools in the community that Metaflow integrates with, like Docker for containerizing your applications and these processes, and Kubernetes for, in turn, orchestrating the Docker containers. On top of that, if you're going to do fine-tuning, you need to be using one of these frameworks that implements backpropagation and allows you to actually learn something inside of the model's weight space. Autograd engines is one way to describe this. Basically, I just mean the deep learning frameworks that people use as developers. And then on top of this, there's tons of fine-tuning frameworks that are emerging. If you look at each of these different repositories on GitHub, there's many, many, many fine-tuning repos that have 10,000 stars and tons of developer interest. And we have seen people kind of run the gamuts across all of these different tools, some coming from Mosaic ML, some coming from NVIDIA, some coming from Hugging Face. The team that builds Ray is building a lot of things around fine-tuning. So our approach is that we integrate with all of these, essentially. And we're kind of viewing the task orchestration layer as something that we want to be able to enable our users to be able to use any framework they prefer at this level of the stack. So with that in mind, now I want to actually build up, for the developers in the room, I want to actually build up what is Metaflow, like very concretely inside of your Python code. How are you going to use it? And then by the end of the talk, we'll tie the thread back to some of these fine-tuning frameworks and show you what does that actually look like. So here we see the most simple kind of Metaflow workflow that you can have. Every time you write Metaflow code, it's going to be subclassing this FlowSpec object. So you can see here we have the hello flow object, and there's 2 Python functions that are inside of that class, and each of these is annotated with the step decorator. So this is defining, basically, we'd have, if I go back to those like circle diagrams of the workflows, there's going to have 2 circles, kind of one says start, pointing to one that says end, is the structure of this workflow. And building out these functions and connecting them in different ways and layering on different Metaflow features on top of them, that's what Metaflow is at the end of the day. And that's how you can kind of get productive with it and start to do all the fancy stuff we'll talk about in a bit. So kind of continuing on that pattern, we're just going to move up the stack and sort of discuss briefly what each of these different categories of the stack looks like in the context of fine-tuning. So when it comes to data, this might include something like data coming from Hugging Face Hub. So we've built an integration with Hugging Face where we can kind of cache and version different assets that you store in Hugging Face. This not only makes it faster to consume these artifacts into your Metaflow code, but it also makes it much easier, especially when you're working in teams, to kind of avoid these patterns where if you run this workflow 100 times, you're not downloading the data 100 times from Hugging Face. You can kind of cache it into the same S3 bucket, and just keep hitting that cache over and over again, and also start to construct more of a solid lineage as you do so. The other item that we see here is our Snowflake connection. This is a new thing that we've built at Outerbounds that essentially kind of helps automate a lot of the Snowflake user access management, things like this, RBAC controls. But a bit of a separate talk probably for another week to go deep into the Snowflake integration. On the compute side, we have an integration with NVIDIA, who has DGX Cloud. So we have, basically, they have a bunch of GPU capacity. We have an integration where you can kind of lift any of these Python functions into the cloud is a core use case of Metaflow. And in this case, when I say the cloud, I mean run this first step, just run it locally on the machine that I run the Metaflow workflow from. And when I say at NVIDIA, this is going to dispatch that job to run on NVIDIA's DGX Cloud, where here I'm asking for 8 H100s, which obviously my laptop is not going to be able to have that kind of horsepower on it. We have also, like, again, these slides are all online, so feel free to read them after, and there's a bunch of links to all these different features and more stuff you can read afterwards. Another thing on the compute side, depending on the model size, say you want to train the 405 billion parameter Llama model that was part of the Llama 3.1 release, that's going to require more than one node. The cloud providers, they sell virtual machines in GPU increments of 8. With the biggest NVIDIA GPU with the most memory, if you want to fully fine-tune one of the models that's 405 billion parameters, you're going to need a lot more GPU memory. So that means you have to go multiple nodes. These nodes need to be able to communicate, much more complex system to set up. Metaflow takes care of that for you with this parallel abstraction, which is essentially saying, in this case, I want 3 of these tasks to exist, and I want them all to be able to communicate together. So we're going to, in this case, instead of the NVIDIA cloud, we're just going to run that on our Kubernetes cloud as the compute platform. And Metaflow takes care of kind of constructing all of the different environments needed to have these tasks communicate with each other for things like distributed training. Also, another recent thing that we've worked on is kind of bringing Slurm into the picture. Lots of legacy compute systems use Slurm. It's also just a preference among different audiences, like especially the HPC crowd often has a Slurm cluster and they don't want to move to Kubernetes. Point here is just to demonstrate that Metaflow works with whatever compute platform you want. It also works with AWS Batch, things like this. On the orchestration side, there's a bunch of different ways to kind of slice what does orchestration mean in machine learning. The two angles I'm going for here is that Metaflow lets you run whatever Python code that you want. It gives you a scaffolding to kind of run whatever module you want. So in this case, I'm importing this post-processor function, and then I'm using the integration Metaflow has with Torch Run to launch my own custom script in the same exact way that I would run it if I was logged into the box myself and kind of doing things from the command line. This is going to take that and put it inside of a Metaflow flow, which as we keep moving up and we start talking about how do we deploy these workflows, automate them, schedule them, trigger them based on events in the database, things like this, becomes extremely beneficial as my laptop gets out of the loop. I don't have to push buttons anymore to see things happening. The second piece of orchestration that we're highlighting here is this retry decorator. This is one of many examples inside of Metaflow core, where in this case, what we're going to do is say if there's some ephemeral error, retry the task 3 times. If this is running on a schedule and you've done a bunch of really expensive computations on GPUs, you probably don't want to just keep, I have to wake up in the middle of the night, debug it, figure it out. Now that GPU went away and I have to wait for a new one to spin up, these kinds of things. So the idea here is that Metaflow has a lot of kind of built-in tooling to help make this, to help improve the developer experience here. Versioning, in addition to code versioning, Metaflow can work with GitHub in certain ways. What I mean here is specifically the versioning of these different Metaflow runs of these different flows, as well as the tasks that become, that Metaflow is fundamentally orchestrating behind the scenes. So here we're just setting a string value into this self.model.version. Whether this runs on my laptop or on Kubernetes, it's going to be accessible in all the other tasks to Metaflow. And of course, it doesn't have to be a string. It can be a pandas data frame, NumPy arrays, things like this, very complex objects. And in addition to being able to access this in other workflows and in other steps in the same workflow seamlessly, Metaflow also has a client API, meaning that you can kind of go back after the fact and do things like reconstruct the lineage that actually produced artifacts that make things happen inside your applications. When we're talking about deployment, there's 2 modes that we're going to highlight. The first is the schedule decorator, and we'll see an example of what this looks like in a bit. The idea with the schedule decorator here is I'm saying every night at midnight, or you can put it on any cron schedule, I want you to run this whole workflow end to end. And then what we'll see is if we do that and we just wait until the schedule has been run a couple times, we can then use that client API that we just mentioned to sort of track the results, maybe look at difference between different runs, see how the data distributions are changing, and start to build up a custom monitoring dashboard that way. The other mode is getting away from kind of run this on a certain clock time, is the trigger decorators that are built into Metaflow as well. So in this case, we have our workflow is going to kind of wait for certain events, and when those events get sent into the event bus, then Metaflow will trigger this workflow. So that the language there, like when I said event bus, things like this kind of depends on what the actual production orchestrator is. So Metaflow integrates with Airflow, Argo workflows, many different systems that do this kind of thing. But the important thing is that Metaflow is kind of taking care of handling these events as they come in and running these workflows whenever things happen. In this case, when we have a new instruction dataset version, let's rerun the fine-tuning workflow. Similarly, then we can kind of see as things come in, we'll be able to see over time how things are changing. Finally, at the modeling layer, there's a bunch of stuff we could say here. But the one thing I want to call out is that in Python ecosystem, especially with a lot of these LLM packages and different tools that folks want to try out, the dependency story can be a challenge. Metaflow goes to great lengths to help developers be more systematic, is the way that I think about it, in terms of how you define dependencies. Instead of just throw your requirements TXT file or PyProject TOML into the repo and call it a day, Metaflow actually forces you to pin these versions. You can also use Docker images if you want. But doing it this way kind of ensures consistency across different executions that I do and as well that my teammates do. And this is kind of just part of a much broader system that Metaflow has. So I like this schematic a lot, which is from the Metaflow documentation, which is kind of showing the different nested layers of how things are actually happening in the environments that Metaflow is helping you manage. Really without being an expert in software engineering, a lot of the idea here is let's get data scientists and research engineers, these folks, to use the best practices from software engineering without having to learn them all from scratch themselves. So now to just kind of go rapid fire and like kind of do a quick summary of all the different things that we've just seen. So this step is kind of the core of everything, right? And these are all just Python functions is the way to think about it. For fine-tuning, we have a lot of features like experiment tracking. Metaflow has a whole UI built in where you can kind of log custom artifacts, build whatever dashboard you want out of simple Markdown, different matplotlib figures, things like this. There's fault tolerance through features that I already discussed the retry decorator. You can also catch certain errors selectively. You can scale compute, whether that's horizontally. You can run thousands of Kubernetes pods in parallel that are all doing the same thing. Obviously, you can't do that on a laptop. Then we also have these primitives for gang scheduling, which is the kind of the core thing that is needed to do distributed training. Vertical scalability, so you can get multiple GPUs on the same node. You can do monitoring. Again, you can compose these dashboards using a mechanism that we call cards, which lets you log seemingly arbitrary kind of data into the Metaflow UI. Metaflow also has a whole collaboration system built in on top of what we call namespaces. So whenever I run a flow, my username gets attached to it. Whenever a flow gets run in production, that's a different namespace. When my colleague runs a different flow, it's in their namespace, and we can resume and kind of compare across these namespaces as we build on each other's work. Dependency management, I've already talked about that a lot. There's a kind of a narrative that we call fast data, which we've written like several blog posts about this. But Metaflow has its own S3 client that essentially just saturates the S3 connections in a way that the kind of the lower level Boto 3 client libraries that AWS provides don't. But across any cloud, this client can basically help you move data very fast between the data lake, the data warehouse, and the task run times that actually do work inside Metaflow. Further kind of more features for experimentation. So the project decorator is another way that you can sort of deploy different versions of these flows side by side, kind of track certain changes in this way. And then, of course, the orchestration piece kind of all comes together when we start deploying to the orchestrators like Argo workflows. In addition to all these built-in functionalities, we've been spending a lot of time kind of building integrations with other tools that our users are interested in, and as well, other companies have been building a lot of stuff on Metaflow as well, integrating their tools. So Weights and Biases and CommentML have both built their own experiment tracking integration, so you don't have to use the Metaflow UI necessarily. That comes very seamlessly. Model checkpointing and caching. We've built our own kind of custom solutions for PyTorch, Hugging Face, the common library, the common modeling frameworks. Compute integrations, you can run Metaflow on any cloud that you want to. On the Outerbounds side, we've been kind of investing a lot in this integration with NVIDIA's DGX cloud, as well as CoreWeave, which is another kind of popular GPU cloud these days. Databricks, sort of the two big ones that we see over and over again are Snowflake and Databricks. Monitoring for these kind of fine-tuning tasks, having some way to kind of wrap the task runtime with something that checks how is the GPU actually being used. In this case, we're going to use the NVIDIA SMI tool to do so. But these are all kind of built into Metaflow for you, so very easy to use as a developer. Yeah. If you don't mind. Yeah. Back on the first box there on the left top. Uh-huh. What is WAN-DB and what is the use case on WAN-DB? Yeah, WAN-DB is, well, it's an abbreviation. The company is called Weights and Biases. It's fundamentally an experiment tracking tool. They do a lot more now, but that's kind of how it got started. And essentially, it gives you the ability to kind of connect. You can define runs however you'd like, and then you can log different information about what happened during those runs for things like model training or data processing, something like this. And then you get like very nice tables in their UI that kind of show you everything. How are we doing on time? Okay, cool. So I just want to go then, before we close out, I want to go like rapid fire through 2 examples, and then I kind of just want to show you a little bit of some of the stuff that I've been saying many words about, but I want to show you in the UI what it actually looks like when some of this stuff is moving around. So the first one is going to be an end-to-end fine-tuning example, no distributed training. This is like all single node. But the idea here is that we have kind of one workflow here where we're using what the TRL library, which is another project from Hugging Face called Transformers Reinforcement Learning. But they have this very nice abstraction called the trainer that's common to the Transformers library and TRL. But this SFT trainer is one of the most commonly used tools for people who are fine-tuning LLMs. And then Bits and Bytes is a framework for doing essentially parameter-efficient fine-tuning, if folks are familiar with that term. Actually, that's another good quiz. Who here, quick show of hands, knows what I mean when I say PEFT, or parameter-efficient fine-tuning? Okay, nice, probably about 10. And it's a way to basically still fine-tune the model, still customize the weights, but do so in a way that's less expensive. But the point of this workflow is that we're going to be training these models, and then we're going to be dumping them into a database. That database then is going to be connected up to an inference server. So we have a little script that we can run on the inference server, and this is going to know how to kind of smartly pull the things that we trained in this Metaflow training run. It's going to know how to pull that onto the inference server, unpack it, and then run it in a scalable way. In this case, we're using an open source project from NVIDIA called Triton. We wrote a blog about this, which is linked here, and the code to do so is fully open source. One thing to note there as well that we found during this is that it's actually also super fast for classical ML models as well. Triton has a lot of tools built in to, say, run tree-based models from XGBoost or scikit-learn, and these are extremely fast, like more than 10 times faster than kind of the alternative methods that we are testing against. So kind of like continuing in this direction now, like we're doing the LoRa training, whatever framework you can kind of produce these with. In this case, we're looking at the NeMo framework, which comes from the folks at NVIDIA as well. The thing to focus on really is this adapter store. Can I see my mouse? Yeah. This adapter store here, think of this as just like a database for these LoRa things, which are kind of like, they're sort of like chunks of a model, but they're much smaller than the full model themselves, but the weights are represented in the exact same data format. And the idea is that you can store all these up, you can fine-tune and produce all these little LoRa adapters, and then you can very quickly pull them into the inference server, which in this case we're using NVIDIA NIM, which is a project that NVIDIA is pushing very hard right now, and definitely check it out if you're interested in generative AI and building your own systems. They have a ton of different Docker containers for all the language models, vision models, many different things in the healthcare domain. But these NIM containers can consume the LoRa adapters, so you can have kind of thousands of them if you want on the same GPU server, and you can keep swapping in and out these LoRa adapters very fast on the fly. So we have some examples here, which since we're running low on time, I'll just skip ahead. But the upshot is that kind of the thing that most people want at the end of the day, whether you use NIM or whether you use VLLM or some open source inference serving engine, is people want this API, which matches how OpenAI kind of defined the standard in the industry right now. OpenAI compatible API is sort of the buzzword. But this is one of the 2 modes that we hear people asking for. The other mode is batch inference. So this is one that fits very naturally with the Metaflow workflows themselves, where what we're saying here is we want to have one of these NIM containers, actually in this case 2 of them. We'll spin them up as kind of little sidecar processes that run in parallel to the Python function that we're running Metaflow with, and then we can do things like kind of call into this Llama 3.37 dB model. We can do it a bunch of times and just completely saturate how much of that model's throughput can we achieve through the lifecycle of this Metaflow task. So this both keeps costs low, but it also kind of maximizes throughput, and it's very, very much unlike kind of if you just call it to OpenAI, you have no idea when you're going to get rate limited. You have to kind of make your software in a whole different way if you call somebody else's API versus doing it on your own. So these are kind of the 2 endpoints of that first workflow. Oh, this slide I just threw in here just as kind of like a, hey, if you doubt that this NVIDIA NIM project is for real, this is Perplexity's stack as well. They're kind of using these same serving tools and achieving like very impressive things, in my opinion. Now, the second workflow, which I'll show you an actual example quickly before I pass the mic, is a kind of more end-to-end where we're going to connect these two workflows. We're going to connect a training workflow to an evaluations workflow. So we're going to use Ray as the distributed training in this case. And we're going to have n nodes. In this case, it'll just be 2 nodes, just to keep it simple. And then we'll use this just another decorator called Metaflow Ray. And what this enables is basically forming a Ray cluster out of these parallel Metaflow tasks. So we can do things like distributed training, which Ray is very, very good at. And the upshot is to produce Ray checkpoints, which will be versioned with all those same guarantees I mentioned earlier in the cloud storage that Metaflow helps set up and manage for you. And they'll all be versioned to get to the runs, to the tasks, so on and so forth. Once we have that set up, then we'll be able to kind of trigger whenever we get a new checkpoint or whenever the training workflow finishes. We'll be able to trigger an evaluations workflow and kind of see that system start to go end to end. You can kind of project out and imagine now what if you had a model optimization step as well in a different flow, and then you had some inference deployment pipeline as a different flow, and you can kind of imagine how these systems start to get built out phase by phase. So that was my last slide, and what I wanted to show you is that when this is actually up and running, what we'll see, I'll make this a bit bigger. What we'll see here is we have 2 of these workflows running. One of them is the training workflow, one of them is the evaluations workflow. So if we click on the training workflow, we can see a bunch of different executions have happened already. I've basically been running this training job every 5 minutes. I'm kicking off a new one for the last couple of hours, is what we're seeing here. So if I click into this one that's running, we can see that these 2 parallel tasks are kind of in mid-flight right now. And if I click into one of them, we'll see what kind of the logs that are coming from the Ray cluster that we've formed are happening. We'll see an example of that GPU profiling that I mentioned earlier, where this is kind of the real-time data streaming in about our GPUs being used. So in this case, the actual GPU processor itself is near 100%, but the memory is very low, so probably kind of overkill on selecting the GPU. In this example, the data is not coming from Snowflake. It's an S3. Yeah, but these charts, so this is part of an a feature that's built inside of Metaflow, the GPU profiler. So NVIDIA SMI is gathering the data, and then the charts are produced with a data visualization framework called Altair. But yeah, there's a lot more details into this behind the scenes. We can chat later if you're curious. But yeah, these charts, the point is these charts basically come for free when you use Metaflow is the idea. You don't have to set anything up as a user. You just need to know the decorator name to add. So now, when this workflow completes, what we'll then see is another one of these torch evaluation workflows automatically get triggered. And this is visualized in the UI as well here. So if we look at the dependencies on the deployment, we can kind of see the full system that we're starting to build up. And Outerbounds is kind of generating this visualization of the full system for you. So every 5 minutes, we train this workflow. This is a distributed training job, so you can kind of imagine like scale it to the moon, like very, very powerful system. And then whenever that completes and produces the new checkpoint in our cloud storage, we can run this evaluations workflow. Kind of furthering in that direction, you can also then like go trace back in time and say you want to run the evaluations from any checkpoint that you produced in the past, and you can kind of start to build up a lineage system. Which I think is kind of the punchline of this talk, that we're kind of bringing these concepts that are very experimental right now, and we're kind of trying to move them from being possible to being more easy and being more streamlined and ready to plug into production software systems reliably. So with that, I will give the mic back. What's up? I am not hiring. If you're looking for a job, I would suggest talking to my colleague, Savin, who is also here and could give you some much better information on that front. Yeah, here's some more resources as well to get started with Metaflow. Definitely check out the documentation. We have a bunch of these examples are open source at Outerbounds GitHub. And there's a lot of great case studies of how companies are using Metaflow. A lot of them are doing Gen AI, LLM stuff. So check out outerbounds.com/stories for more information there. Thank you.
Thank you so much. All right, up next we have Matt Wyman, but there was a question about getting the slides on Discord. I've made the request. They're saying it's going to happen. No cost.
This time.
This time, yeah. And I believe Matt's going to help engineers kind of figure out their RAG and et cetera pipelines. I think he's going to talk a lot more about that. Thanks very much.
Does that mean it's a global option? If there's no cost, does that mean it's a global option?
Yeah, I mean, that's a good one. Yeah, I mean, give me the slides. Don't give me a hard time.
I mean, what if they pay you? I mean, then, but it could get a little better. It could be better than zero. Thank you, everyone. In fact, I see a couple of familiar faces because we've been doing more of these AI camps. My name's Matt Wyman, part of a company called Ocario. I'm the co-founder and CEO. Longtime engineer, grizzled veteran of the dev tool space, and normally we would go into a very technical demo and talk about the product and talk about all the various things we can do, but I decided today to editorialize a little bit and hopefully get some feedback from you about the gap between prototyping and getting to production and the problems people are facing getting from one to the other. So one of the questions we didn't ask earlier, and I'm very happy to be after Outerbounds because I think it fits very nicely. How many people here have merged a PR? Yeah, like everyone? Okay. So a lot of things we're talking about are going to get the same response in a year or two. And this is sort of a theme I've been repeating over and over as we talk. But more and more, I think people are starting to wrap their heads around the various complexities in building with LLMs and building networks. It seems that every day there's another pattern that's showing up, right? So 2 years ago, we were talking about LLMs. We were mostly talking about generation. Maybe it was some code gen was kind of the tip of the spear, so to speak. That was the edge. But now we're talking about agentics. People said, oh, agentics is way in the future. It's not going to happen yet. And now agent networks are all over the place. And people are starting to scratch their heads and wonder, hey, I've got multiple prompts calling different models in an orchestrated manner. Is that an agent network? I don't know. Maybe it is. Some of them are autonomous. They can take action. They can call functions. So we're seeing more and more complexity. And it's showing up every day, every week. Just recently, Sora was announced. I'm not even sure Sora is the best one, but Sora was announced. So we're seeing all this multimodal stuff. So the world keeps expanding. And we keep hearing about these amazing successes. And what's interesting, this was actually 6 items drawn from a Forbes article. And they're wildly different. One of them is an assistant for clinical diagnoses. One of them's cybersecurity regulations. There's a code gen piece up there and the developer assistance, feedback analysis for web analytics. It strongly suggests that these were all projects well underway. These were all ideas well underway before this last, call it, 9 to 18 months. What we're actually seeing, and this comes from a Datadog report looking at costs and spend in cloud compute. In 2023, about 10% of cloud compute was GPU compute. 10% of spend was GPU compute. In 24, it's jumped up quite a lot, 14%. But the interesting observation they made, it seems to be anecdotally, it's what we're seeing as well as we talk to various customers. It's all the cheapest GPU. It's the stuff you experiment with. It's not the stuff you take to production. It's not the robust, high-performant systems that you would use if you're actually deploying at scale. It's the things you would use if you're actually trying to figure it out, if you're trying various projects. So it leads me to believe that there's a big gap. I don't think I'm the only one to believe this. It's been talked about quite a lot. But there does seem to be a big gap between what people are doing and planning and what they're actually getting out into the world. And to that end, how many folks here, aside from founders who have full control over their entire engineering stack, how many of you could actually decide one day to call OpenAI and push that all the way to production? Anyone? One person. Awesome. I want to work there. It's just not something you can easily do. There are too many steps, and there are too many concerns. Most organizations are still learning about LLMs. They're still trying to figure out who owns them. Is it a data science team? Is it the developer? Suddenly we've got this whole new way of thinking. There's issues of stability, cost, performance, security, it goes on, right? Basically, it all comes down to one thing, risk, right? There's a lot of risk in taking the unknown and fundamentally, because it's not deterministic, it is the ultimate local maxima of the unknown, and trying to get it out. Lots of things can go wrong in the system, right? You can, if you're building a RAG, you can return wrong context and give bad information. Last week, my co-founder was sort of showing a fine-tuning demo where the LLM would actually invent the fact, even though the context came back with information, because the actual question wasn't answered in the return context from the vector database, the generation in the final step actually substituted what turned out to be a right answer to the actual original question. But it was completely broken from a consistency standpoint. It's a nuanced issue, but we're going to see more and more of these. Error loops, plan changes, problems where the network can't resolve to a single answer. And of course, in all of that, we see agents talking about avocado smoothies when they're asked to help with a retail checkout flow. So what are our choices? And this is where I start to editorialize a little bit. It feels like people are thinking primarily about what I'll call traditional gated QA, where they're trying to test the heck out of every aspect of it, or they're doing the classic YOLO, which most of us now live in the world of YOLO, where we push to production, small amounts, start to roll it out, make sure it doesn't work, do some error reporting, have a good logging system, etc. I don't think that's actually the right question, but let's take it apart for a moment. The QA model, well, there's no way you're going to cover every use case. It's not even close, because by definition, it's non-deterministic. You can ask it anything you want, and if you have an agent network with different tasks, the combinations are going to be very, very difficult to manage. You can't guarantee that it doesn't leak or lie. You can't guarantee, if actually, maybe the one you can do something about is performance. Maybe that one you can start to figure out what the performance of the system. That doesn't mean you have to throw all of this out, but a traditional QA gated model is not going to easily get from engineering through compliance and the CISO and security out to production, because there's no amount of proof that you're going to be able to put forward that guarantees that you're ready. On the other side, well, I think we all understand the YOLO problem. A vibe check's not enough. And since you don't have great visibility into what's actually running in the system, you actually aren't even alerted when there's a problem necessarily. You could just be waiting for an article to come out on the next New York Times front page. In fact, and rather ironically, this little graphic in the corner here, which looks fine, the arrows are completely wrong. That machine would actually fall apart entirely, because the gears are going to the right, and the next set of gears should be going to the left, but they're also going to the right, and then the bottom one we get stuck. So this is just, it's like a little tiny thing, but these things slip through. So that really doesn't work either. I think the answer is to go back to the who. Who's building this, and what are these different personas that are getting merged? So originally, the world of AI, if you will, but let's be honest, the world of models was a data science activity. Models were not generated daily, they were generated over a period of months, sometimes quarters or years. It took a huge amount of effort. All the data was understood, it was trusted. Data scientists are highly metric driven. Developers are system thinkers, fundamentally. They also have to move at a much faster pace. They need to get things out every few hours, every few days. They're in this constant delivery mode. Even if it doesn't get all the way to production, still the ticket gets closed, the work gets done. And then finally, the SME, the subject matter expert, right? They're often only tangentially aware of how the systems work, but they understand what good looks like. And when it comes to a model-based application, the SME is the actual person who understands whether it's working or not. The other people have to eventually go reference an SME to understand, is it good or not? So somehow we have to mix all this together. And again, editorialing, if that's a word, I believe that it's around aggregating a small set of seed data, using synthetic generation not like a data scientist to build models, but using synthetic data to generate use cases. In other words, the behaviors you're expecting. Think about the I/O of the behaviors of the system, isolate individual nodes of the system, and then think about it end to end. Once you start to define those scenarios of behaviors, you can expand upon them, then you define the metrics. What are the actual boundary conditions that we're going to accept? See how that model behaves. More importantly, see how the application behaves, because models aren't in the application alone. They're mixed in with a lot of other code and a lot of other interactions. Once you have a baseline for how you think that system's going to work, you can now go to production in some small way and start to measure behavior in production against your baseline. And then you can easily aggregate the issues into sort of a new place to generate new data to take the whole loop over again. So in other words, if your system is not performing well with questions about birds and airplanes and you're trying to identify them, great, take those questions, expand upon it with synthetic data, go through and decide, is this a prompt change? Is this new embeddings I need to do because there's a RAG in here somewhere? Do I need to fine tune? I agree, that's sort of the last thing you want to do, but it is incredibly powerful once you've done the other steps. So that essentially is the loop. And so you can't think of it as just QA or just production. I think it has to be this movement between the two, from sort of pre-development. In fact, what we're noticing is our customers who are most successful are generating these use cases, these synthetic use cases, essentially from day one. They're not waiting for a QA moment, they're actually generating it as part of the definition of the application. So, there's one other critical bit, and I think that's the very, very, very specific, task-specific metrics that are not academic, that really are much more about the business case you're trying to solve. So yes, there are all sorts of academic metrics that you should be looking at in various conditions, but you need to up-level that into things that the business can understand and start reporting out to the business how those metrics actually, how your application is actually performing and how the models are performing within that application based on a nomenclature they can understand, the business understands. Fundamentally, that SME, that third person in the list. If the SME gets it and they say, yep, that's working, that's great, perfect. If they say it's not, then they should be able to jump in and point at the few cases where it's not working. And that becomes your next round of synthetic data, your next round of improvement that you then push back out again, and then you hill climb from that original baseline up into a new number. I think this is incredibly important. It's something that's being missed right now in a lot of the conversations. A lot of the metrics being described are esoteric, or just as bad, people are looking at benchmarks that have nothing to do with their actual use case. And they say, you know, model Q is the best model. I think we're going to go use that. It's very exciting because it does astrology really well. But does it actually work for your use case? Is it going to work when you actually apply your rules and your data? I've been sort of throwing around the term of behavioral evaluation or BEVAL. It does look and feel a lot different than what I'll call generic evaluation. Typically, evaluation that many folks are doing, they isolate a prompt with a model, right? Sometimes they swap out the model, sometimes they fine-tune on the prompt side, fine-tune, or they change their prompt, do some prompt engineering, and they start to look at the academic scores. When you start thinking in terms of use cases, your evaluations look very different. They're described very differently, and you follow a different process, and there's some benefits. The biggest one is the debugging. So one of the challenges I find, obviously with deterministic code, you get into production, if there's an error, you can go trap that error, get the stack trace, see the problem, maybe a difficult problem to fix, but you have a lot of clues as to how to fix it. You can trace through. It's very difficult to debug an application, especially a complex multi-agent architecture, when you don't have a lot of hooks to grab onto. But when you start to describe things in this manner, then you do get those hooks. You start to understand which node it was that misfired or gave you a poor response, and you can start to trace that through the system. I also think it helps with cycle time. So again, the developer thinks about hours and days, data science, a longer time scale, although I think it's coming in. But once you get into the application world, you will be working in days. You're not going to be working on long time scales. And so you need as many clues as you can get to quickly resolve the various issues. And then, of course, at the bottom, that business clarity. And ultimately, I think it's the business clarity that allows us to get up the hill to production, allows us to resolve the issues with the CISO, allows us to resolve the issues with the business so they can trust. Because fundamentally, the risk component, when you start to talk about blue score or the Levenstein distance between the original summarization and the user's edit across it, this is confusing. But if you say, we only had 2% edits on the summarized text, more likely they understand, okay, that was much closer to something that actually worked. We can trust it. So I think this is where the gap is sitting currently. It's hard to articulate whether the applications we're building are trustworthy. The metrics we're using to describe those systems are difficult to comprehend, and therefore we have a hard time championing the applications we're building into production. And so I think that's the sort of the gist of this overall perspective here. GPU shows its experimentation. People are getting stuck on how to get through to production because they're either taking a QA mentality or they're taking a YOLO production mentality, and they're not mixing the two. They're not focusing in the right place on the use cases, and ultimately they're not sharing metrics that can be understood. So there it is. I'd love to hear responses. Questions? Yeah.
That might be obviously expensive to get in terms of money and time. And also, if you want to get enough of it so it's statistically significant as well. I guess this is just.
So I'm going to repeat it just so people can hear. The comment was getting attention from an SME can both be expensive, time-consuming, and difficult, and sometimes even hard to find the right person to come and comment on it. I agree, fundamentally. It's one of the things we're focused on is helping bring that person into the loop at the right time on the right items, so they're not just awash in thousands of rows of data and they're trying to sort through what good and bad looks like. We've already figured out, hey, these are the subset of interactions, these are the spans coming from production, these are the spans that don't match the checks that you had put in place. Therefore, your most likely problem area is with this particular prompt and model. Here are the examples, here are the numbers, and then they can go through and provide feedback in a much narrower fashion, which completes the loop, if you will, with collaboration back to the developer. But we very much agree, and we see that same pattern. Just to add on to that really quickly, I've been in dev tools for a long time, and it's only recently that SMEs and product people are coming to the technical demos and the technical reviews from essentially the very beginning. Quite often they're much later. The product manager's not always there when you're having a conversation about architecture, but we're starting to see PMs and SMEs in those conversations because they're answering key questions about what the system needs to do. So there's an interesting change afoot in that space as well.
I got a comment.
All right.
So two pieces. One, behavior-driven development really lends itself well to when you have your sort of business goals well defined up front to sort of achieving these in LLM sort of settings. So I'm assuming, I think you've alluded to that being sort of a part of the process, right? And the other part is when you have a lot of these different groups coming in the architecture discussion, but the architecture itself is technical, that gets muddled very quickly. Because then you're spending a lot more time explaining parts of the piece that either a technical team might want to own themselves, and it might not have the impact that other teams with the very short learning period believe it has, right? So you gotta also still maintain a new way, like you said. You can't get stuck in the old ways. There needs to be a new way to articulate what part of the conversation needs to be had with what team, because that's the most efficient way to do it.
I agree, and the BDD is also aligned to the test-driven development, the TDD mentality. There's some mix there of those two ways of thinking about what's the outcome before you get started. I would add on your architecture point, which I agree with, that when you start to see SMEs learn what's possible, there's a lot more trust that the various models will infer the right next step or articulate the right plan. And so we're seeing some interesting effects where there's more lean in, because they're less worried about owning the architecture, they're less worried about owning how it's going to be built. They're at least in the examples that we've seen, faster to sort of adopt, if you will, and trust that the system works after they've seen a few good examples.
Yeah.
All right. Well, thank you, everyone.
Yeah, sorry to hijack. Any other questions? I'm going to go to him first because you got like a couple questions in, but I'll come back to you.
Do you have a favorite app that's publicly facing that does this well now? Like as far as exposes an LLM-based AI tool to the user and handles the fact that it might start talking about avocado smoothies. Like everybody has to figure this out, right? And it can always occur. And so there's framing to the user, that sort of thing. You guys help clients do this. Maybe it's one of your clients, maybe it's somebody else, but I'm just curious if you have a favorite example of this is what it looks like to do it right.
Yeah, there are a few that I really like that do it well. My favorite actually is it's not as visible from a consumer standpoint. I'll give you two. One that's a little more visible, another it's a little less visible. The one that's less visible is in the automotive space. They're actually helping technicians figure out the right part to use when performing a repair. And that is a very tedious process, and the taxonomy of parts is very difficult to understand. A oxygen sensor and an air sensor are in completely different parts of the car, and so most models will get that terribly wrong with very, very negative effects for people. One's in the engine, one's in the passenger compartment, and there are other similar things that can literally kill people if you use the wrong fluid in an electric car that's is conductive. People can be hurt. So they've figured out how to build this entire pipeline with multiple agents and a RAG and a very complex system that understands how to answer what are very cryptic questions written by technicians with gloves on in a shop and answer those questions accurately, and they're doing so with a loop. So that one's very impressive, a company called Predi. Another that we really like is an agent network called Wayfound. And they actually do something, not only do they build a low-code agent network, so you can just walk up and build your own outbounding agent, but they've got a fantastic loop in there where as you're using it, you can start to build directives that you inject, and then they are using these types of behavioral loops to make sure that the directives you're injecting are actually being followed by the agent network that you're building on the fly. And in that case, there aren't any engineers who are building it. It's being built by SMEs. So it's an impressive use of these kinds of loops, and also happens to be a customer and a partner, but it's one of the first ones that really leaned into figuring out how to build that kind of loop that's self-reinforcing. All right, love to talk to folks afterwards. Oh, there was one more, sorry.
Yeah, so I'll take it faster. Maybe it's a loaded question, but you decide how you want to answer that. My name is Uday. Thanks for this opportunity to GitHub yourself and Eddie. I had a lot of technical questions, but I'll get to the marketing. What are your success stories for 2024? How do you build the strength in those success stories from your platform? How you are helping Eddie with his engineering challenges? There are many engineering challenges, and just share any success stories and how you reduce the cost for that particular use case.
So I think there were a couple different questions in there, and I think maybe afterwards we can talk at length about many of them. But the first and most important from our standpoint is we're helping people get from that ideation prototype phase to actual production, right? They're just it's amazing how many folks are stuck. They get down the road, and then they have a hard time figuring out those last few pieces to get to production. And to do so, they have to be able to, all the things I just talked about have to be in place. You can't just have a portion of it. I think one of the biggest challenges we're seeing with teams and engineering, specifically engineering teams, is when they try to put off the metric thinking until the end, and they focus mostly on the systems thinking first, and then they wind up stuck. And truly, they're jammed because they have these beautiful machines and they have no way to ensure or articulate how it will perform and how it will get to the next step. And often, we've now seen multiple organizations pull back when that happens. So I think that's the biggest risk that's sitting out there right now as people are trying to build. And I think the key that we're seeing is when you put this type of workflow in place, you're able to move faster, you're much more predictable, and you know what's working, what isn't. So you can actually start to layer in the steel thread of a system and then start to hang more and more complexity off of it. And
I just wanted to add security to that challenge, right? How do you secure the data, particularly in their production?
Absolutely. Security is huge. So thank you, everyone. Available afterwards. Happy to take more questions afterwards.
Thanks. So I got a couple of asks while I was talking about the QR code. I'll put it up again after Ahmed's talk. But right now, up next, we have Ahmed from Spotfire. He's going to give his spiel. A big hand for him, please.
All right. Good evening, everybody. Thank you for staying for the last talk. I hope they saved the best for the last. Joking. So my name is Ahmad Fatahi. I'm a Senior Director of Data Science at Spotfire. My goal of this short talk, 10, 12 minutes, I promise, and a bunch of it is a demo video that I'm going to speak over. So hopefully it's not boring you, is to tell you who we are, what we have done, and get feedback from smart people in the room, and given what you'll see in a minute, what we have basically been through over the past year and a half, 2 years, building what we call Spotfire Copilot. Very happy to help. We have leveraged the open source developer community quite a bit, the fruits of their work. So if there's anything we can help back, I'll be happy to help. So 2-3 minutes on what Spotfire does and who we are. So the the name of the game is Visual Data Science. It is Spotfire, a visual data science platform serving industries such as energy, such as life sciences, and manufacturing. Many large names, brands are our customers. Some of them we don't have the permission to put them on a slide like this, but pretty much any popular brand name in these industries you can think of are our customers. And our end user is the subject matter expert, as opposed to a generic BI tool that typically serves HR or finance or general analyst data crunching. Our user base is the chemist or the mechanical engineer or the yield engineer in a high-tech manufacturing chip-making facility. And to put things in scope, on the left-hand side, you have these data science platforms where your user is typically a statistician or a data scientist, a coder to build a model. Right end of the spectrum, the users are the analysts who are, mainly they can build nice visualizations and number crunching and things like that. What we are trying to marry is these two sides for those subject matter experts who may not be data scientists, but they can understand quite a bit about their business if we enable that persona to work with their data and quickly turn around, do a number of iterations. They can run their business much more efficiently. And the last story about the company, it started in 1996 as a research project in Sweden. It was acquired by TIBCO in 2007. Some of you may have heard of TIBCO, the information bus company. A couple years ago, we were merged. TIBCO was merged with Citrix to build this umbrella company called Cloud Software Group. And under that umbrella, Spotfire was carved out again as its own business unit to grow more freely. So now we are at the demo phase. Before I get to the demo, I just define a couple quick terms for you because they're critical for a demo. So the demo is about naturally a industrial process. So imagine you are a engineer, mechanical engineer, or yield engineer, or pharmaceutical. You're in charge of something, building something or monitoring something. At the end of the process, some of the measurements, you have to make sure they are both in range and consistent. So it can be capacitance between two pins of a chip, or the density of a certain chemical in your drug. It has to be within the bounds and consistent. So what this measure process capability, or CPK as we call it for short, basically it measures that. And all you need to remember is the more the better. If it's close to 2, it's very good. Below 1 is not typically acceptable, and the closer you get to 1, it's better. And also throughout the demo, you'll see some measures of or mentions of statistical process control, or SPC, which is basically statistical measures of statistical properties of an industrial process. So I'm going to use this video. So I'm going to speak over this demo. All right. So this is Spotfire. On the left-hand side is the standard canvas where the user has loaded their data in a table. It's in memory. The product itself, Spotfire, can create a bunch of charts and comes with a bunch of models. The right-hand side is what we have added over the past 1.5 to 2 years as a GenAI-based layer on top of the tool. So the end user, the subject matter expert, can interact with Spotfire features instead of through the menu items through natural language. So the right-hand side is where the user comes in. As you see, the user types in, visualize the number of runs, rules, violations. Basically, that's a statistical or SPC measure by these 2 parameters, dimensions. So it generates the tree map based on that prompt. It understands the concept of the question based on the column names in the data tables, and it translates that under the hood to a Spotfire API to generate that visual. The user can ask questions about the data. What are the top 5 parameters with the highest violations? And it again understands that, turns that into query, and responds the question to the question. The next one is the same concept, SPC. We want to generate a report or have it explained to me in natural language so I can understand what's happening in this page, or create a report and push it to my colleagues. So instead of starting from scratch, so it explains this chart for you, both the obvious ones to save you time and efficiency. In some cases, makes actually some interesting observations too, some key observations, outliers, minima, maxima, and things like that. The next, we are getting back to that CPK concept that I was telling you about. So imagine you're a user, you're given a data set, you forgot what CPK is. So you can start asking about that concept. The back end of this is a RAG use case based on your own internal proprietary documents. This is not our document. It can be any concept of your company that you can privately load, and it becomes available through RAG. The user can continue to ask questions. What is a good, what is a bad CPK? If they're not sure, it again comes back with references. And as you see, 1, 3, 3, and closer to 2 is good. The analysis continues after the user understands what CPK is. They want to actually calculate the CPK. So you can extend Spotfire by writing code. So what the user asked is, can you create, we call them data functions, can you create a data function for me that calculates the CPK? And none of this is hard-coded, none of this is in the product. It's all through the interaction with the LLM. The Python code is created. It's not always perfect, as all of these assistants are. All the user needs to do is to just review the code. In most cases, it's either runnable right away or like 10, 20, 30% correction, and it works. All left to do is to hook up this function that was written by Spotify Copilot and basically tell the model that to run on this column in this table and run the results in this other table. So basically, that what you saw was hooking up the input and output to the model. Now to the back end of Spotfire, it has a visual data wrangling module as well, so the user can visually see what data goes where and how the CPK is calculated. Now that it ran, and we saw for a second the results, now we want to have a quick exploratory process into what we are looking at. So out of all the values, 4 of them are above 133, so not very good. 26 is below 1, so it's actually a horrible process quality-wise. Now the user wants to go one step further, create a visualization and report. So next is create a visualization, sort them and color them based on good, bad, medium. And all of this is, this video is normal speed, so it's literally this fast. So the visualization is created. Once the user says, yeah, I like it, it creates that. At that point, it becomes like any other native chart in Spotfire. So if we want to go back and adjust the color, so the bad ones are red, good ones are green, and so forth, to make it bigger, at that point, there's no difference between this chart that was created with the Copilot and any other traditional chart. Next step is to generate a report out of it, or explanation, description. So the description is created through the LLM, Spotfire Copilot, and it's the text of it. It can be copied and pasted either into Spotfire itself in a text area for a full report generation with the visual and the text, or outside. And the rest of it is basically showing how we can shuffle things around, make it look like a good-looking report. And the last step, right after this adjustment is done, is basically exporting your report to a shareable PDF format. And as a user, you don't have to remember everything or leave the product or Google search for how it's done. So now we ask, how do I export this page into a PDF? This mode goes back to our help, our RAG based on our own documentation. And the result comes back, and when the user finds it satisfactory, they follow the steps, as you see, and export it to PDF. And that's the end of the demo. I'm going to spend a couple minutes on the architecture and some of the lessons learned, and I close. So in summary, we have built all of these features on top of an existing pretty mature product over the past year and a half. All basically the gist of it is the top 3 are RAG use cases, pretty straightforward. The rest of them are quite heavily reliant on our internal Spotfire API. So through this interaction with the LLM, sometimes multiple round trips, we turn the user prompt into the corresponding API call, or sometimes SQL query to answer questions about the data, create a chart, or generate that Python script that we saw. Here's the architecture. Nothing too fancy here. We haven't fine-tuned, or we didn't find the need to fine-tune yet. Measurement is actually one of our big challenges. We have thought about it quite a bit, but basically, the UI, everything we saw, is on the bottom right. That's where the end user interacts with the system. We have a package added to the Spotfire server, pretty lightweight. The heart of the system is this orchestrator, which is the quarterback of the system. The non-RAG use cases go through the logic, system prompt, and the LLM, and we are agnostic, by the way. We can work with, or we have customers against GPT. We have customers against Claude. We have a working version of against the Gemini, although in our type of industry, we haven't run into too many of those customers yet, but there are a ton of Azure and Azure OpenAI or main AWS Bedrock. And the RAG use cases are to the left of the chart, and we allow each company to privately, securely set up their own instance, upload their own internal documents, sometimes a handful, sometimes hundreds of these daily reports that they upload, and they make them available to the end user through RAG. And these are a bunch of resources, and this is me. So in case you have any questions, if you want to talk to me about any lessons learned, or if you have ideas for me to improve our process or product, happy to help. And thank you for hosting us.
Thank you. All right, folks, as promised, I'm going to put up the Slack link for anyone who missed it. And up next, we're kind of done with the talks. Next up is if anyone really wants to talk about a project they're really excited about, we have a couple of minutes that we could spare for that. And any takers for that, first of all? No one's excited about, no? Is anyone specific? Oh, you are. You want to come up? Yeah, we'll give you 2 minutes. Come on. Well, I was going to do the hiring part. Oh, you're hiring. Come on up. Yeah, heck yeah. I think that's like one of the favorites. Anything?
No, that's okay. Yeah. Hey guys, my name's Anish. I'm the founder and CEO of Lervo Learning. We are an education AI startup, and we're building a personalized learning platform for medical students. We are angel funded, and we are making our first hire, and we're looking for a founding back-end engineer that can handle like back-end, cloud, infrastructure, security, that type of stuff. Unfortunately, we would not be able to do any visa sponsorships, but if you're interested, come talk to me. I'll be around. Thank you.
Anyone else?
Is Spotfire hiring too?
I mean, is Spotfire hiring? I'm not hiring. No, not yet. Keep looking, though. All right, let me put that link up. Anyone who wants to share any projects that they're really proud of? Anyone? Can
I share one?
Yeah, absolutely. Come on up.
Wait, can I open a browser?
If you'd like, but I only have 100 million things open here. Just use this. Go for it. Just go for it. Ignore my link. Actually, don't ignore my LinkedIn page. Just come say hi, connect with me. But, yeah, the mic.
Wait, how can I go back to the search?
That's a good question. Just go to, yeah, there you go.
So I don't see it.
You want to just talk to it real quick?
Yeah. So I don't see it, but if you Google search LF Luis my LLM on GitHub, like you'll find this project that I just finished, and pretty much I made an LLM from scratch. I didn't use like an open source model that's already out there, and retrain that. I just chose my own model architecture, own size of the model, and found my own pre-training data, and trained that, and actually got some pretty good results. So why does this matter to anyone, right? If it's a personal project, I think the reason it matters is because when you start working on more complex things, like that first demo, once you get there, that's very prod heavy. That has to be very well done. But before you even get there, you have to understand how tuning works, how fine tuning works, how pre-training works, how working with large data sets works, and how distributed training works. So if you want to learn more about that, you can take a look at this project, and it should really give you a really good primer on how to do those things, and help you move onto more production-like environments, and also better understand what's going on out there in open source. But yeah, that's the project.
That's awesome, dude. Thank you.
Yeah, I wish it could have been shown up there.
Go find them if you're interested. Yeah. I wish I could use a computer, but apparently I can't. Yeah, try that. Oh no, you're gonna overwrite my slide? No, don't worry about it. I'm just messing with you.
Is this like in a different countries?
I am definitely in the US. But you know, it
Yeah,
might just be in my bubble somehow.
Yeah, none of those.
Maybe try the GitHub search.
Yeah, try the GitHub search.
Wait, I think this is me.
Yes.
Okay, and through here I can get to my GitHub, I think. Yeah, there it is.
Might as well hit connect while you're at it.
And then, okay, yeah, there we go. It's this one. And like, I even made like a little nice, like README. So I made like a nice README to like showcase like how this project is like set up, and also like how you can like reproduce this on your Mac. It's not gonna train fully, or reproduce it on a on any NVIDIA like setup, and also why I made my model the way it is. There's like a little explanation on why it is the way it is, and results. You know, like they matter. Like it trained really well, and like some examples of like at the end. So like here it shows in the beginning. If you type in like HTML stands for, it'll give you like garbage, but by the end, it's able to figure out that it stands for like hypertext markup language, and have like more examples in the code as well. But yeah, hopefully it's helpful to you guys.
What framework did you use?
PyTorch. It's like literally PyTorch modules, my own transformer, my own like rope implementation. It's like literally my own everything in there. But yeah. I don't know how to do that.
I think it's just probably one of those things that. It's tiny, guys. Wait, can't we convert it into QR? Let's see if this works.
But yeah, if you'll have like any feedback or questions, reach me.
What's up?
Try that.
So like the cost in energy or money? So I know the money cost. It was like to train it by itself was like $150 because I only did like 8-9 hours of training on 8 A100s. But to like even get there, I had to spend like another $150 to like do my test my setup, like test various things. Thankfully, I got like free credits from this company called Vessel AI, and yeah, thanks to them, I wasn't able I didn't pay for any of it. But yeah, like. Oh yeah. Again, it's a very small model. It's like 269 million parameters. Yeah.
Great, thank you. We have potentially one more